I guess for a game, if it gets popular, already having a website or something set up for it means that someone else can't just come along and pretend to be
Yeah.
on a website and make money off of your work.
Yes, which is actually a note I was going to share later. So before, real quick for the video, before the break, we just went over policies and kind of starting to look at software and stuff now, talking about things that were great, like later when we release games and stuff. Was a conversation right when they hit the record button. So along that effect, another thing, I would recommend not releasing games under your own name. Gamers can be opinionated, and they will let you know what their opinion is, quite relentlessly. So that would be my suggestion for game development: is don't release it under your own name, company name, or some sort of pseudonym, so that people can't quite so easily track you down to let you know what their opinion is. They can't show up at your house and knock on your door to tell you what they think about your game.
I mean, personally, even on Facebook, I don't even use my name, so
probably a good idea. But that's one of the less pleasant points. Hopefully, it's going to be a fun class because we're making games. We're designing games, right? So some of the discussion boards are just style choice things. What color palette would you use? What type of music do you think goes good here? Questions like that. We at least want to think about those thoughts. So we were looking at policies and stuff. I loaded some software out. Let's just kind of do little demos on these softwares. I already have Blender and Inkscape installed, so and get over here. So let's try. Let's look at Inkscape. I think I have Inkscape installed. Nope, it's installed. Okay, that must have been when they finished putting the shots on the trailer. So one of the last steps. So this is the 2D software I'll be using. You can use whichever one you want. I'm not going to require a certain graphic software. Use whichever one you want. There are a couple features that you want to make sure you have though. Is that downloading? Sorry, I should have ran this during the break if I would have. I thought I installed it the other day, but now that I think back, yeah, they said the truck was finished, so I was ready to leave that lobby. And must have forgot I hadn't installed it. A couple of things that we want, right? Here in this class, we're programmers. So we don't want to just rely on random mouse movements and then try to figure out where the positions are and stuff. So you want to make sure you have a way to type the values in, not just for like the position, the width, and the height, and depth when we're in 3D. You want to make sure you're able to type all that stuff in. And that way you know exactly what it is when you get to your code. So I got to run this installer while this runs. Let's talk about a couple of a few things to put on the board. I'll pick really quick. Oh, that's not please. You got that far ahead. Oh, take a second to install. So, in general, I guess I'll just talk for a moment while that installer runs. I have a lot of fun with game development. It can be time consuming, and I guess at times, like all programming, it can be frustrating. It's a lot more time consuming than anything else. That's the big thing, because games, we're going frame by frame. So we're only ever doing small things. In general, the code for any particular object in the game is going to be simpler than some of our business software that can get really large and needs to do a lot of complex things. But as a rule of thumb, it seems like those large, complex business softwares are take less time to put together than video games. So what is a game engine? That's our main thing we're going to work with. Engine is a term reserved for software where it's a conglomeration of different softwares all put together. So a couple things that are very important is we need some sort of rendering pipeline. And what a rendering pipeline does, a pipeline moves stuff from one spot to another. We have if you didn't know it, that vertical bar on the keyboard right above the enter key, that's the pipeline symbol. So if you're typing in a terminal, you type one command and put that pipeline, and then type another terminal command, and it takes the output of the first command and sends it directly to the second. So pipelines for moving things, just like the words used in regular, like what oil pipelines, water pipelines, all of that. And we need to move the graphics all at once, separate from anything else. That way, anything else happening in the other calculations and stuff don't interfere with those graphics being moved. Some sort of physics engine. Those who have had me before know the answer to this question. So it's actually not physics, like the laws of physics that we need from the physics engine. Because we can write different laws of physics, and as long as they're consistent, it'll still work for the game. Different gravity levels and things that the player can get used to, and have physics apply a little bit different than they would in the real universe. But what we absolutely have to have from the physics engine is the place where the interface where physics happens. For example, if I'm standing here, if I jump up and come back down, right, there's a lot of physics applied. The force from my body or from my legs pushing upward, equal and opposite force pushing down on the ground. My legs push down on the ground, and then equal and opposite force pushes back from the ground, and that's what raises me off the ground. Then gravity takes it and pulls me back down. So all of that's like the laws of physics, but it all happened at the bottom of my feet, right? Where the interface between the soles of my shoes and the carpet here. That's where the physics happens. So what we have to have from a physics engine is the boundaries, the shapes of things, the edges. We have to know where our stuff exists at in order to make it interact with each other. It's quite often going to happen with our graphics. So it'll be somewhat connected to the rendering pipeline, but it's going to be separate. Then we need some sort of processing software. Something to do the calculations and tie those things together. These three are what we can't live without. There's going to be a whole bunch of pieces. This list is going to, basically this semester, we're going to just keep adding to this list. But we need some sort of tree structure, right? The processing software, that's our logic for the game. The physics engine, that's our the physical component. It just so happens that since people have been building these libraries for a while, we have some really nice physics engines to use that already have all the laws of physics from the real world programmed in there. And we just ask for the function, don't have to spend a lot of time on it, but that, the boundary of stuff, I'll call it the shape. That's the shape of the things. And then our graphics. So this is the start of our tree. Our logic is always going to be the root of the tree. Some sort of logical component. And then we'll need our physical component and our graphical component. And it is a tree structure. To save space, our game engine is going to write it with the indentation. So it'll, instead of having a branch there, it'll come over. And maybe this will. So it like puts the root of the tree up at the top and then uses the indentation level to show the branching on the tree and stuff. The data structures that it forms and how we process it in general is going to be a tree, which means we get very rapid speed in the connection of these things. Obviously, we have other parts too, audio engines, audio buses. We'll see those in a couple weeks. Yeah, lots and lots of parts. Right after class today, I'm going to send out a video that has all of the nodes built into Godot that we use to create other scenes. And then once we build those new scenes, then those scenes become nodes in other scenes. Sort of redundancy thing. So let's start looking at examples. So I just ran that installer for Inkscape while talking about that. Right, this is day one of class. This is preview mode. The Blender stuff. Yeah, back to that. We got Godot here ready for a new one. We can open the 2D software, so Inkscape. Because this will be, we'll have this assignment come up first. So it's taking a while. Hopefully it won't take too long. Maybe I'll close some of this stuff so I don't overwhelm the computer. I always teach off the cheapest laptop at Walmart. That way I can make sure everything works on the cheapest laptop at Walmart. Yes. So yeah, any students in this class should be able to work on the cheapest computer at Walmart. So, and most people have a better one than that. So should be good to go. So just set up some things. So I'll review checkerboard, dark appearance. That sounds good. Colorful. Some basic settings. No, I'm going to skip over the donate thing and go to new document. It is open source software. Similar to Adobe Illustrator, the difference is this doesn't have the CMYK colors, which are for printing. RGB is source light. Red, green, and blue mix when we're seeing the color in the source light, like on the screen. Reflected light, like what we learned in elementary school, fellas back then, your teacher in elementary school probably said red, blue, and yellow mixed to give everything. That's reflected light. So when light hits something and bounces off of it, we see what's missing from there, what was absorbed. And when light comes directly from the source to our eyes, we see what's present. So they mix different. And it's not red, blue, and yellow. It's actually cyan, magenta, and yellow. The little kids might not know those things. So Adobe Illustrator has those things to get better control over printing the colors. But we don't need that at all because we're making game objects. Yes.
We've also CMYK is additive and RGB is subtracting color. Mixed together on it subtracts for RGB.
Yes, the source light adds together and builds up new wavelengths. And that's the ones we see. And when it reflects it, some of the wavelengths are going to be absorbed and we see what's missing. But that's just a side note. Made the Zoom made the, somebody's leaving sounds. Hope their internet didn't get cut off. Oh, maybe they'll be back. So first thing we wanted to do, up here at the top, there's these 4 boxes where we can type in X, Y for position, and then the width and the height. Whichever software you're using, make sure you have that functionality in there. That'll be important. Otherwise, when you go to write your code around it, you'll just be guessing at the numbers. And works a lot better when we're certain what our numbers are going to be. So I'm going here and set some sort of size here. Here in Inkscape, go to File and Document Properties. We have all these different things. We're going to be on screen, right, for game components. So first thing, want to switch all your units to pixels. And maybe type in some number. We'll come back and size it specifically to whatever we draw afterwards. Let's do 512 by 512 for now. Make sure it's transparent, all settings. Yeah. And the first graphics assignment is due in module 2. It's going to be a spreadsheet. So for module 1, maybe click around on the software and kind of play around with it and get ready for that big assignment. Then our basic shapes, right? Draw a square. Front game is a tile match, so you can just put together a bunch of colored squares that to kind of make your tiles. So, different controls over here for the colors where
getting different color.
switch an RGB color up here. You get some sort of RGB color, right?
Because that's what, I mean, what that's the other that's bar. So you're getting the color actually changing, it was just showing us through.
Oh, okay. Yeah, so when you select the object up here under object, there's a lot of different options. Fill and stroke, this will get all your colors and things. Yes. Hue, saturation. When it was created, they said luminosity, but nobody uses that, so we've kind of changed the lightness over the years. You will also see HSV. That's what Godot has, and Blender, they have HSV, which is hue, saturation, and value. Yeah, let's talk about colors. This one, we use that one instead of RGB because of intuitiveness. So think of a circle. I'll put 0 degrees on this side. 0 degrees, and as we go around the circle, it's 360 degrees, right? 0, 360. So a third of the way around would be like 120 degrees. And 2/3 around, 240 degrees, and then we're back to 360 degrees, or all the way around the circle. So that's our U. And that's which tint or red, green, or blue we're using. So at 0 degrees is red. As we come around 120 degrees, that's our green coloring. And at 240 degrees is our blue coloring. And as we move between them, we get different mixes. So green and red mix together to make yellow. Red and blue mixed together gives us purple. Have browns in there, oranges. I'll try to pull up a picture of it when we get over to Godot. And that's our hue. So how far around the circle did we go? And then saturation is how intense is that color? So I like to think about like dyeing a shirt. So you have a white t-shirt and some a bucket of colored dye, like tie dye in the shirt or something. You want to, right, you don't want the white t-shirt, you want something nice and colorful. There's different ways we can apply that dye. We can just like barely tap right? Barely tap the t-shirt to the dye. And just get a tiny, tiny bit where it's just a little bitty hint of it. Or we could throw the t-shirt in the bucket of dye and leave it there for a day or two and get really, really rich colors. That's the saturation. So how much of that color is applied? And you can think of that as moving in and out the circle. So like 0, right in the center of the circle is when we like hold the t-shirt above the bucket of dye and maybe catch a couple of vapors off of it, but pretty much nothing. Right? Just barely tap it, and then when we move out to the edge of the circle, that's like when we threw the t-shirt in the dye and leave it there for a couple hours. It's gonna be well saturated. And then the lightness, think about the room you're in. If you had like a rheostat switch, if you turn the lights, instead of just having the lights on and off, you have that a rheostat to get every value of the lights, where you can dim them and get them brighter or darker. And that's your either lightness, brightness, or value. They kind of do the same thing, but when you get really technical, they're different. Godot has value, and Blender has value, and Inkscape has lightness, like we just saw. So that's why we usually work with those colors. And after a little bit of practice, most people feel it to be more intuitive. Yes.
And also in Inkscape, on the fill and stroke, there is a drop down for the color wheel, which I find a lot more intuitive than.
Oh yeah. So here's that picture I was just drawing. See, so 0 degrees, it looks like it's going counterclockwise. 120 degrees, we get to green. 240 degrees, we get to blue. So we just go a little ways around it. I like the one in Blender better. I already closed Blender, didn't I?
So Inkscape does actually, it has HSL, HSV, RGB, CMYK.
Yeah.
HS.
Wait, it has CMYK?
Yeah, it does.
Okay.
There's a little drop down in the top.
I haven't looked in a while, but
CMS, whatever.
for a long time they couldn't do CMYK because Adobe has it copyrighted. So nobody could do that but Adobe. But
yeah.
Good mind when going So yeah, here's a nice view of it. There in the center, you can see everything's just white, and then the color gets denser as you move out towards the edge, and changes as you go around. And then the bar over here is like a little light switch, a dimmer light switch.
So neither RGB or CMYK actually have the color wheel for whatever reason.
Yeah, because there are different types of coloring. The wheel doesn't apply it. It doesn't work on the other types of coloring. Why is that not open? There it goes. Okay. So we have our basic shapes. Those probably aren't the ones we want to use, because if I click this, notice that this rectangle is just defined by 2 points. Right, there's only the 2 points that define it, so can't get a whole lot of manipulation off that. We're good for tiles and stuff. I'll just delete that. Circles and stuff are the same. So when we probably want to use, if you come down here, there's a pencil tool. I'll just draw some random shape here. You can draw everyone. Down at the bottom are like quick colors. You can choose a few different colors. And then open up the fill and stroke one and adjust those more precisely. But the second one down, you can see we can get back to all of those points in space that make up that complicated polygon. When we get to the skeletal animation, that's really, really useful, because then the computer has a lot of points to manipulate the shape we give it to make the movement look very smooth. So you want to use that pencil tool, get some practice with that. Another thing you're probably going to want is layers. Make sure your software has layers available. There's objects we can put things on different layers. I'll just do a couple quick shapes. So like if I draw a very quick rough head of the cake, that was supposed to look like a character's head. I don't think it didn't look so good. So undo. Control Z is undo, right? Take a couple tries. And maybe we're on a little bit slower, draw something that looks like a character's head. And then I'll come down to the quick colors at the bottom. Maybe. I don't see anything that. Okay. Yeah, something that looks roughly skin colored. And the big thing we want, if I draw the next piece, so like a shirt for the character. Maybe a green shirt. We want to make sure we can get back and edit everything. Right? Some software, once you draw it, you can't get back and make any changes to it. So it's important that we can get back and edit stuff because it's like everything, doing multiple drafts goes a long way. And for the first week, you're just going to want to play around with this. And in layers, we can rename all of this stuff. So like this is the shirt. And just double click on it to rename it. I quickly draw and I come here and copy the color from this over to that other shape. So you want to make sure you have all of these editing features and just kind of click around and get used to them. And that'll be good for now. I don't need to finish the character on the layers.
You see, but I think he uses your gas, or is it, or is it vector? It is. But
This is scalable vector.
oh, vector.
Yes, I'm going to save air in a second. And then once we're, next week you'll have to do sprite sheet animations. That's where layers are going to come in really helpful. So I'm going to select everything on that layer and hit copy. Then over here, add a new layer and paste it in. Paste it in. Kind of position things next to each other. Notice I'm on layer 2. If I hit Control A, the normal select alls, notice how it only selects stuff. So it separates stuff. And select all of that stuff without on layer 2. That's important for the display animations. You move around. And you want to make sure you can resize stuff. So like it's up here at the top on this one. For purposes of loading it in, we probably want our character thing that would be finished. I'm going to stop halfway through here because we're just in preview mode today. We probably want it to start at 0, 0 and be some sort of size with like a tile set in our game. So like 32 by 32, nice and small. And then we come over here and delete this layer. And delete that layer, take out everything at once. Let me zoom in. Another thing that can be nice here when we select this, so once we get the basic draw stuff going, there's the filters, and there's a bunch of filters that can make things look really nice. So button filter kind of rounds that all. Do that. Make things start glowing. Those only work for the exports. When you export it as a PNG file, that's the only way you see the filters. The SVG, you'd have to go in and draw all the details. But once you're, make sure you resize it before you do the filters too, because filters will affect the sizing. So once you get to that final size, you come in there and maybe apply this filter feather thing. That didn't work. I was just picking one at random, so like on our skin, looking things, you go to blurs or materials, I don't know. I'll go to materials and do like a wood texture to give it a little bit of some shading in there. And then on the shirt there, like this, and apply bright metal. Yeah, something like that. And you can make the shape start looking really nice very quickly with those materials. Yeah, and for the first week here, that's what you're gonna do, play around with those. And, keep in mind that, the filters only apply to the ping exports, but either one of them can go and works in Godot. I'll hit save, some sort of name. Go to libraries. So, yeah, I'll just go ahead and put it in the project. So I'm gonna, oops, not that one. I'll go in that game project, create a new one, put a folder here. Images or assets, whatever you want to call it. Drawing, that's a good name for it. When we do that, it automatically imports it into our game engine for us. And exporting, if you go to file and export, notice it's kind of big. So before you do the exporting, and probably should do it on the SVG, we might want to go back to document properties and resize it now that we know what the size is. So in this case, it's just 32 by 32. But when you do a sprite sheet next week, every frame of the animation is going to be 32 by 32, and you might not know the exact size it's going to be until you get to that last little part. And I'm going to document and see codes, and yeah, it just fills in that shape we need, the page, a particular selection, or you can do a custom export. When we get to skeletal animations, it's helpful to just export each piece individually. But for now, we can just export this as a thing. And looks like it's going to the same thing. And then when we go over to Godot, since I saved them in the game project, they'll automatically import when I open that back up. Next time the engine has focus, it'll import those for us. And same thing with Blender. We don't need to do anything special with the softwares that I'm using here. You can use other ones. The engine is integrated with a few different things. So now we have a 2D image. So we create a new 2D scene. You can draw use either one. All right. A root node. Actually, I don't want that root node. Delete that one. Here's another node. It's a character, so we probably want a character body 2D. Anytime we see body, that means physics are going to somehow apply to it. So there's that will be our logical body. Back to the tree. So there's our logical body, and we have the graphical body. So I'll just grab one of these, either the ping or the SVG. I like to use SVGs myself because scalable vector graphics scale nicely, and we have clarity, however big or small they are. So, and there's lots of different screen sizes available. So it looks like the character body is centered here at 0, 0, and the image is off to the side. So I'm going to come over here to transform data. Hopefully you remember this from the 148 class. I know anybody that had me for the class, I would have drilled transform data in. This is mostly what we're manipulating with all of our stuff, graphics, 2D graphics, 3D graphics, and in the game, 90% of game programming is we're just changing the transform. That's the location of something, rotation, and scale. So where's it at? How is it oriented? And how is it stretched out or shrunk down? How does it fit on the screen? That's most of what we're manipulating when we program these. So we'll come back over and over again. Transform data is our transformation. Where is it at on the screen, and how's it rotated, and what scale value is it? So I'll put that in the same spot. So there's one more part for the bare minimum tree. So no configuration warning, has no shape. So we need our physical shape of the object. And for that, we just pull up a collision shape, collision polygon, and draw something maybe precisely around the character, or collision shape. And those, when we load in a shape, rectangular work. Just want to set the shape, to whatever works for your game. It doesn't have to be an exact thing. You could do a polygon and perfectly trace that polygon that we use there. Or actually, wait a minute, polygon. When we load in a polygon, we can use the information in our SVG file to create that polygons so that it would be a perfect fit every time. Or maybe for a fighting game, right? We only need, for a fighting game, we only need collision shape on the hands or the spots where they're going to make contact. Everyone's going to be different, but we have to have at least those three minimum to get that going. And then the root is the logical body. That's going to need to have the script. For some reason, when I downloaded 4.4, it does not have, it did not download the templates. That's why I went ahead and downloaded them again today to see if they're just not included in 4.4, because I went and looked it up. Since 4.0, we've had really nice character templates. Has everybody seen those? We have a character body, and then when you add a script to it, it's already assigned to the arrow keys and the space bar and movement, and it's really quick to get going. Those script templates weren't in there when I downloaded it the other day. They're really useful and easy to load in. So I was debating on whether I should go find them, or if maybe to start off the class, we should just make that our first step on Wednesday, is making a script template. What do we think is a good starting point? Instead of using that starting point somebody else had that needs a lot of editing, we'll start there on Wednesday and just kind of see how to do that, how to set up a template. I'll go ahead and create the script. So this is one of the first things you want to check on when you go to a new engine is how is our loop set up each frame of the game. There's usually more than one way. Godot, the one we're working on here, I'll talk about the others as we progress. We're just in preview mode today. Godot we decide which one's going to have priority. So there's always going to be some sort of initialization. So this is the Godot scripting language is based off Python. It looks a lot like Python, but it runs through a C++ compiler. So it compiles to C++ code. It's really, really fast. That's pretty common. It's like Unity. We type the script in C#, but then that C# script gets run through a C++ compiler. So it gets compiled into our fastest language, which at times gets annoying because most of us use especially if you use VS Code or something on Microsoft, because it's going to automatically compile your C# code. And then when you go to use that script in Unity, it has to be recompiled to C++. But it forces us to write cleaner, neater code. That's why they did that. Godot, they wanted something easy to work with, so they copied a lot from Python. And then it just runs through a compiler before running. So to create a function, we use keyword function. And then an underscore ready. This is our initialization function. And then like Python, the colon and indentation. This is where we initialize everything. And just like Python, if we indent, we have to have something in that indented area. So initialize stuff. I'll put pass for now. We're just talking about it. And then there'll be a function that gets called every pass of the game. It's different in different engines. And they're set up differently. For example, Unity uses time. Do we call it at the beginning of the frame, specifically at the end of the frame, or just at any random point in that particular frame? What Godot goes with is priority. I don't think it's gonna make a difference on anything we apply, anything that fits in our time constraints here. But we either have this function, process, and it takes in a parameter called delta. There's a floating point number. I should use predictor text. So process returns void. So there's a big difference from Python. So this is return type, and it's going to be a void return. We could leave that all, but if you treat it like Python, like a dynamically typed language, it will be slower. So it's probably a bad habit to get into. Right? Anything that fits in our time constraints in class, we're not going to notice that. When you're making a big game later, maybe on your final project, it might start to get big enough that you'll notice the difference. So process, unlike, well, Unity gives it, do we do it at the beginning of the frame, the end of the frame, or any point in the, let the game engine decide what point in the middle of the frame. Process gives us graphics priority. Yes. Graphics get priority. Or we have underscore physics process. Again, the parameter delta, and it returns void, and this gives physics priority. So not going to matter until you get to something big, but when you're when you wrote a really awesome game and you're maxing out somebody's GPU and CPU all at once, and something's got to give, is it more important that your physics be absolutely accurate, and then you can, like, maybe the graphics pass through each other a little? Does that makes sense? Maybe your graphics glitch out for a split second so that your physics stays absolutely precise. Or is it more important for that particular game that the physics can get a little off as long as the graphics are absolutely correct? Right? You don't want your graphics glitching out or looking like they pass through. Which one's more important? And that's not going to show up until you have a big game and you're bogging down resources and something has to give. If that makes sense. And obviously the answer to that's going to depend on the game, or maybe even the level of the game.
I think it's something we'll do, we could run basically beneath that.
Yeah.
Because well, it had to be optimized that much for it to work back in 83.
And that would be an example of physics priority, because the game continues to work right even if the graphics start glitching out a little. Different engines do it different. Make sure whenever you every time you get a new engine, you're paying close attention to which one has priority. Yeah, and different engines all have different strengths and weaknesses. The reason that we hear these three together over and over and over again, Godot, Unreal, and Unity, they are not competitors for each other in any stretch of the imagination. They don't even have the same goal, right? Unreal, their intent is solely to push the boundaries of hardware. Godot is an open source project that people around all over the world have contributed to. So their thing is just to make a game engine that's easy to work with, and that's quick and easy to work with and somewhat reliable. Unity is a data tool. Everything about Unity is just a way to sell your data to more game folks. Right? They have different goals, but what they have in common, right? The reason you see them together, come over here. So in our inspector panel, we'll talk about this more later. The engine editor in these three is dynamic. We can change what's in that inspector panel If I just say at, export a new variable, I don't know, we'll call it speed. It'll be a floating point value and set it off. Oh, there it already changed. Notice when I said at export, I added a new field to the game engine editor. That's what Unity, Unreal, and Godot have in common. Our editor is dynamic from the scripts we write. I'll just put a speed in there. That's probably not good. Oh, then I'll go ahead and save this just randomly. So we wrote that script. If I go over that project saved, new game project, that console thing's just, it's writing all this other stuff, right? So here's, it really doesn't want to open that. Open with some objects. There we could type that ourselves. We could type the project information. This is what it scans for whenever you go to open things. Is it scan and it'll take all the subdirectories looking for this file, see where it is. You can see it's not much to type it up. Just a few lines in TOML. Has everybody seen TOML before? It's used pretty regularly for Python configurations. Object, and then the parameters are involved with that, attributes of that object. Object, the attributes of that object. And configuration style language. So we could type it all up, because when the editor does it, it's going to throw in a whole lot of extra stuff too. Go in this Godot folder. Ignore stuff, scene group. Yeah, so here's all the stuff about the actual editor that we're using and configurations on that. And you see it just goes in the text file. But if the editor's doing it, it has to include a whole lot of stuff that we might not need in our game. So especially when games get big, we can get rid of some of that overhead by taking all that stuff out of those text files. For class here, we're just gonna do this, then Blender 3D modeling. Oh, sorry, one more thing before we do that. Here in the images, this drawing, the one that wants to open Chrome here, that's gonna be our SVG graphics. So open it with the text editor. You can see it's just XML. So we have SVG tag with a whole bunch of parameters, some other stuff. Then we get down here, here's the path that we drew. So there's our starting point. Go to that point on the screen, and then we go to this XY point. And then another XY point. Whoops. Another XY point. And you can see how we're getting all those XY pairs, and eventually that filled out a polygon. So that it's stored in human readable form. We could do editing on it here if we wanted to. There's a lot of points on that one I drew, but it can be edited, and it's a long list of numbers, right? I don't know if we'll be able to squeeze it in this class. It definitely didn't make it on the online shelf, but this is a text file with a list of numbers. To get into this class, you had to have had at least 2 programming classes by now. So everybody should know that if we have a text file with a long list of numbers, we can go in there and manipulate those numbers dynamically, pretty easily from code. So we might see a little bit of that. That's more intensive things, but it's yeah. Hopefully a power you realize we have, and then there's a lot of that, especially like AAA game development, where everything has to be perfect, where you're just manipulating those numbers in your vector graphics. 3D modeling is also vector graphics. I'm just going to delete all this stuff. This is done entirely in Python. I'll go add, mesh, cube. Over here's the scripting tab. If you haven't seen this before, down at the bottom, here's the instruction that just ran. So can copy that last, oh, whoops, that was the deleting everything. This is the one that just ran. So it's written in Python. So if we import the VPY module, there's the instruction to make a cube, which 3D modeling, if you haven't seen it before, we'll see it in more detail. Basically, what we do is connect the dots. So we have vertices, just some edges or some points in space. We say we're give them some sort of a position in space, move them around. I click subdivide this into like 12 subdivisions. Oh, whoops. Like everything. Then subdivide it like 12 times. So we get a whole bunch of these little points in space. Grab them and move around in different areas. Let's hit G. That's how we grab stuff. And start manipulating it until we get the shape we want. And then once we have the vertices in the right spot, we connect them with edges. And when there's enough edges to enclose a full polygon, that's going to be a face. So it's kind of like connect the dots in space. We'll see some more of that soon. We'll have a 3D modeling assignment that also has to be animated in module 6, I believe. And before that, so module 5, we will need to use Blender to make very accurate sized pool walls and pool table. And then we'll go over to Godot. Blender does have a physics engine. We'll go over and use Godot's physics engine to set the masses on all those, and then open the script and apply set things up so that a player can apply force and have a pool simulation. Completely accurate one. So a bit of a preview on there. Let me share my screen. And once again, and Blender 3D modeling is all about the transform data, right? It's the orange, select the object, the orange one, the location, rotation, and scale. And really what we're doing is location, rotation, and scale for every vertex, edge, and face on there. Vertexes don't really scale, but we scale the edges and that moves the vertices and the faces. So transform data is the big thing we're working with here. We'll see more as we progress. For those who haven't had me before, I've been working on this Blender plugin for a couple of years. It's from an old plugin I had that automatically generated a bunch of models, and one of them, the most popular one in there, was the human shape, just a blank human with all the proportions correct, so that it would the artist could just sit down and start adding details and not have to spend the first hour and a half or 2 hours trying to get the proportions correct and have a good proportion starting shape. So I pulled that out, the human one out, and added green and close to it. And the plugin isn't finished yet, but I have it as a Python script that I will share with you all at some point. So that you just have this 3D starter model with all the correct proportions and clothes on it and stuff, and a skeleton in it, so it's ready to animate. I'll eventually finish the plugin and submit it to Blender. Maybe be a really useful one. At the very least, it'll be on GitHub, so that everybody has it. I'll put it someplace where everybody has access to it. Open source software is nice like that, when everybody can make contributions. But that is something I will share with you all. That is will also be good for practice with the animations and stuff and graphics. So you're not starting from the very beginning every time. Good little practice piece. So most of the preview stuff there. Wednesday we'll kind of jump in and get started with some in-class examples. Anybody have any questions or anything here today? Usually not many questions on preview day, right? Most days we'll go a little bit, we'll be out a little bit earlier than this, because, yeah, my plan is to go for about an hour, take a break, go for about an hour, and then the rest of the time we'll be actively applying the stuff, getting practice and all of that. And yeah, so on Wednesday, we'll get started with some examples, making the small tile set and loading in, working with the tile maps and getting ready for the first individual game project. All right, it's been more than 5 seconds since I asked if anybody had any questions, so that was probably plenty of time to type in the chat or unmute. I'm gonna assume that means there's not any. If you have any questions, reach out anytime. I'm always happy to help. Otherwise, I'll see you on Wednesday. Everybody have a great day.